Welcome to your Finite Math Lesson 1.1, Slopes and Equations of Lines. So today you will calculate the slope of a line and you will also write the equation of a line in various forms. Okay, if you will recall, slope is just the rise over run. It's the rate of change for a line. And so if you take any 2 points, it's y2 minus y1 over x2 minus x1. So we want to find the slope of the line containing the following points: -4, 6, and 8, -4. So the first thing you do is you pick one point to be point 1, the other point to be point 2, and you label the coordinates accordingly. So I've got x1, y1, x2, y2, and then you use your formula. Slope is y2 minus y1, so -4 minus 6 over x2 minus x1. So 8 minus -4, be careful there with the minus -4 because that's going to be plus 4. So you end up with -10 on top, 12 on bottom, and that fraction reduces down to be -5/6. So your slope is -5/6. Alright, now if you will recall from Algebra 2 and Algebra 1, there are several forms of an equation of a line. The one we probably work with the most when we're graphing is slope-intercept form. Y equals mx plus b. M is the slope and b tells us the y value of the y-intercept. The y-intercept is 0b, so that's given to us right there. Point slope form is a good form to start with information. A lot of times you'll know a point in the slope, so you can get started and then work towards slope-intercept form. It's y minus y1 equals m times x minus x1. The plane x and plane y are the variables. M again is the slope, and then x1, y1 are coordinates of a specific point. Now the fancy form is standard form. It's ax plus by equals c. A, B, and C are all integers, so there's no fractions, and A needs to be positive. Alright, for horizontal lines, you're going to have lines that are y equals some constant, for instance k, and vertical lines are your x equals lines, so x equals k. Alright, so for example 2, we want to find the slope and the y-intercept of y equals 4x plus 7. Reading closely is going to be very important on this chapter, so let's just stop for a minute and analyze what we're being asked to find. We're being asked to find the slope, which typically we think of as m, and we're being asked to find the y-intercept, which is the point 0b. Now let's think about the equation that we're given. We're given y equals 4x plus 7. That's slope-intercept form. So that's in y equals mx plus b form. So we can tell that m is 4, b is 7. So our slope, or m, is 4, and our y-intercept is the point 0.07. Example 3, we want to write the slope-intercept form of the equation of the line through 4, 3 with a slope of 3. So let's analyze this. When it says write the slope-intercept form, that means we want to end up in y equals mx plus b form. And let's think about what we're given. We're given a specific point, so we're given a value x1, y1, and we're given the slope m equals 3. Well, we can't go straight to slope-intercept form, but we can use point slope form, which is y minus y1 equals m times x minus x1, and then we can work with that form and transform it until we get it into y equals mx plus b form. So let's plug in what we know. So we've got y minus the 3 that's right here from the point equals 3 from the slope being 3. Make sure you know which 3 you're working with. This 3 corresponds to m equaling 3 times x minus 4, because that's what x1 equals. So let's see. We could distribute the 3 here and simplify the right-hand side, and that gives us y minus 3 equals 3x minus 12. And then if we'll just add 3 to both sides, we'll be in slope-intercept form. So we end up with y equals 3x minus 9, because -12 plus 3 is -9. And we are in slope-intercept form, so we're done. Alright, example 4, we want to find the slope-intercept form of the equation of the line through 3, 1 and -1, 7. Okay, so we're given 2 points. We know from geometry that 2 points define a line, so that's enough information. So again, let's think about what we're being asked for. We're being asked to write an equation of the line in y equals mx plus b form. Well, we're not given m and we're not given the y-intercept. We're given 2 points, so we know an x1, a y1, and an x2 and a y2. Is there a formula where we could find the slope if we know x1, y1, and x2, y2? Yep, that's right, the slope formula. So y2 minus y1 equals x2, divided by, x2 minus x1 equals the slope. So we'll find the slope, and then we'll use our first point, and we'll be able to use point slope form to get us started with our line. So y2 minus y1 is going to give us 7 minus 1. x2 minus x1 is going to give us negative 1 minus 3. 7 minus 1 is 6. Negative 1 minus 3 is negative 4. Okay, we're going to reduce, and when we reduce, we bring the negative out front here, and it'll reduce to 3/2, so negative 3/2. So now we know our slope, we know m, and we know x1 and y1. We're going to use point slope form. So y minus y1 equals m times x minus x1. And we're going to plug in the appropriate values. y1 is 1, m is negative 3/2, x1 is 3. So what we do now is we work with this form of the equation of the line until we get it in slope-intercept form. So that means we need to distribute our negative 3/2. So negative 3/2 times x is negative 3/2 x. And negative 3/2 times negative 3 is going to be plus 3 times 3 is 9 over 2. So we get y minus 1 equals negative 3/2 x plus 9/2. All right, we're almost there. We just need to add 1 to both sides. When I add 1 to 9/2, I need to write 1 is 2 over 2. 9/2 plus 2/2 is 11/2. So we get y equals negative 3/2 x plus 11/2. And that is in slope-intercept form. I can tell my slope is negative 3/2, and I can tell my y-intercept would be 0, 11/2. All right, and we want to be able to graph lines as well. So if we are using slope-intercept form to graph an equation, so y equals mx plus b, we want to make sure the equation is in the correct form, and then we want to identify the y-intercept, the point 0b, where the line crosses the y-axis, and then we want to use the slope m to find the second point on the line. And then we want to draw a line between the 2 points. All right, so we've got y equals negative 3/2 x plus 1. So from that we can see that it's in slope-intercept form. We can see the y-intercept is going to be 0, 1 from the 1 right here. So we plot 0, 1 on our graph. That's the point where the line crosses the y-axis. And then from there we use our slope of negative 3/2 to plot a second point starting at 0, 1. And you can go down 3 and right 2 to get the second point at 2, negative 2. Just so you know, we could have also, starting at 0, 1, gone up 3 and left 2, and we would have ended up on another point on the line. And then you just draw in the line. Using a standard form to graph an equation. So if you've got an equation in standard form, what is probably the easiest thing to do is to identify the x-intercept by letting y equal 0, and then you solve for x, plot that point, and then go back and find the y-intercept by letting x equal 0 and solving for y, and then plotting that point, and then you've got 2 points on the line. You can just connect the dots. So we've got 2x plus 3y equals 12. So let's go through that process. It's in standard form, so let's let y equal 0. And so we're going to plug in 0 for y, so that's going to give us 2x plus, well, 3 times 0 is 0, equals 12. 2x equals 12, divide both sides by 2, we get x equals 6. So we want to plot the x-intercept at 6, 0. So 1, 2, 3, 4, 5, 6, 0. I'm going to plot that point. All right, so we've got 6, 0 plotted. Now we're going to go back to the original equation and let x equal 0. So you have 2 times 0 plus 3y equals 12. 2 times 0 is just 0. So 3y equals 12, divide by 3, you get y equals 4. So then you would plot the point at 0, 4. So we've got 0, 4, and 6, 0, and then at that point you just connect the dots. And there you go, you've got your lovely line. And horizontal and vertical lines, the graph y equals c or y equals k as we had earlier is the horizontal line through 0, c. A vertical line is going to be x equals your constant, whether you use c or k, it doesn't matter. And it's going to be the vertical line through, in this case, c0. So if we've got y equals negative 1, just go to where y equals negative 1, it's right here on the y-axis, and draw a line perpendicular to that axis through that point. So the graph of y equals negative 1 is a horizontal line that passes through the point 0, negative 1. Notice every point on the line has a y-coordinate of negative 1. That's why the statement y equals negative 1 defines that whole line. For x equals 2, it's going to be the vertical line that runs through the point 2, 0. You just go to where x is 2 on the x-axis and draw a line in perpendicular to it. Every point on this line has 2 for the x-coordinate. You've got 2, 0, 2, 1, 2, 2, 2, 3. Down here we've got 2, negative 1, 2, negative 2, 2, negative 3, everything in between. Okay, guys, that's it. Make sure you try your problems to try on your own. Make sure that you bring your textbook with you next time to class, because our classwork is going to come from your text. I will see you in class. Thank you.